Hello again. This is Math 2270 coming to you from the College of DuPage. The title of this note is In-Game Guidance, and I encourage you to be an active learner as you watch this video. The outline for the video is I am going to give you guidance about what is the content of the proctored exam content. You will be receiving information from the proctors about how to accomplish this, but I will tell you about the content in this video. The second thing that I would mention here is all students will be accommodated, but you must be accommodated beforehand, not in arrears. So that means if you haven't done it so far, you should be sending me an email, and in the subject line of the email it should say math accommodations in capital letters, and then you can tell me other things about the accommodations that you need. I'll forward this to the proctoring agents and we'll work together to accommodate you. But again, this is a priori, not in arrears, because the term ends. And as you know, this final exam is a mandatory requirement for passing the course, and it is comprehensive in nature. So anyway, proctored exam content will be talked about, and don't forget about the accommodations. There's also going to be a take-home component which should help you. Linda is available to help you with this, and also people in Cheryl Martin's center, and so there is a take-home component, and take-home protocols apply. There will be 12 problems up here, there will be 4 here. And the last thing that I mentioned in this video is I do talk about some tools that you probably want to do to accomplish the take-home components. Okay, so as I mentioned in the hour and 50-minute exam, actually it's a 2-hour exam, so it's 120 minutes. There will be 12 numbered problems, and they'll be chosen from the following topics. If you add up these numbers, it adds to 13, and I haven't really decided which 13 I'm going to use. But there could be up to 2 problems that have names associated with them, and we studied many of these. We talked about Riccati equations, we talked about Bernoulli equations, we talked about Clairaut equations, we talked about Cauchy-Euler equations, and we also talked about Legendre equations, and also Bessel equations as well a little bit. So 2 problems that have associated names with them, so be familiar with those. There's going to be, or could be, 1 problem involving Green's functions, 1 problem involving integrating factors, 1 problem dealing with Volterra integral equations, a problem dealing with separable homogeneous equations, and this would include discussion of interval of validity, problem involving annihilators, a problem involving infinite series, 1 problem non-homogeneous system, that is a system of first-order differential equations, a problem with Laplace transforms, or perhaps inverse Laplace transforms, or perhaps both, 1 applying Picard's existence theorem. The theorem is spelled wrong, that should be REM. And 1 problem involving variation of parameters, and 1 problem involving exact equations. So that is kind of a scope statement, and as you can see, it spans the course. You might say, well, yeah, but there's nothing about numerical methods. Well, that happens here. And there are 4 equally weighted with these numbered problems that will be there. So there's a total of 16 problems. So this is the take-home portion of the exam. And here is, in fact, the take-home portion, and this will be due on Blackboard final exam day by, on, or before the exam finishes. So what you could do, and what I would encourage you to do, is submit this right before you take the final exam itself in class when you meet up with the tutor. And you're submitting this. This will be a legible single PDF upload that will be made to the PDF upload portion. So problems 1 and 2, you're going to consider the very non-linear initial value problem, and here it is. dy dt is equal to, parentheses, t squared minus y squared, sine of y, and this is y at 0 equal minus 1. So this is a difficult problem because it is non-linear. But we know that we can use numerical techniques, and we studied several of those in our course. We talked about Euler techniques or Euler methods, the Hoyne method, and sometimes that is called the improved Euler method. There was a three-term Taylor formula, and there was a fourth-order Runge-Kutta approach. So, and I expect you to completely fill out this table with your answers. A little bit of guidance. Each of these techniques, all four of them, should be used, and a step size of h equal 0.5 to approximate the value of y at 0.4. And you see that you incrementally get up to 0.4 as the value. Now, students should not round off between steps. Keep all the available digits in Excel or wherever it is in the default mode of Excel in the interest of accuracy. In your final answer, show each step round off to 4 digits after the decimal point accuracy. So you round off the final answers you put in, but you don't round off in the middle of any of these techniques. And that was problems 1 and 2, and so because there were 4 of them, and you figure out that I'll just split that and make that problems 1 or 2. In problem 3, you're to use a direction fields program to plot the directions fields associated with the differential equation that you saw in problems 1 and 2. Use the utility to show the particular solutions for a dozen different initial conditions, including the one that was specified in problem 1. And you paste a screen capture of these results into your PDF submission. And then I ask you to write a narrative comment about the long-term behavior of these solutions. And you're to use complete sentences in your narrative. It doesn't have to be a PhD dissertation, but do talk about what happens qualitatively relative to the long-term behavior of these solutions. Problem number 4 is a modeling problem, and we talked about these in YouTube lectures and also in your textbook notes and things like that. But anyway, this is a little bit more involved a problem. So we assume a coordinate system where the origin is the point where the supply pack is released, and the positive x-axis is the direction the plane is flying, and the positive y-axis is downward. So I've defined the coordinate system for you. Assume the horizontal and vertical components of the air resistance both are proportional to the square of the velocity. This makes this a more interesting problem. So part A, develop a system of differential equations and initial conditions to model this for x of t and y of t. Clearly state any additional assumptions that you make in your write-up. So this is a kind of an essay part that I'll be looking at. And then part B, use the appropriate model, and you develop the model here, and as engineers use accuracy to the nearest foot. You don't round off till the end of the problem. Determine the horizontal distance the pack travels. So you see, you let it go here, you're determining the horizontal distance the pack travels, assuming, and here's some assumptions. The plane's original altitude is 1,000 feet above the ground. The plane's speed is constant at 300 miles per hour. Air resistance, there's a proportionality constant that's required there. This is the one you should use. And the pack weighs 256 pounds, the supply pack. So anyway, that is the take-home portion. These are some of the tools that you can use to answer some of those. In particular, these are tools that you can use to answer problem 3, and perhaps problems 1 and 2, but maybe not. This is an excellent program that's written in Java, and it's aligned with MyMathLab, or with, actually not MyMathLab, with MATLAB. And this is a nice program, and I would encourage you to look at it to see if it'll work. And here's the URL that gets you to this. That's one tool you might want to use. Another tool that's a little bit more pedestrian, but certainly very useful, and that has to do with WinPlot. In your syllabus tab, there's a note that professional tutor Jesse Hayes Carver, who is now a graduate student at Illinois State University studying mathematics. But he used to work with me, and he wrote this little guide for WinPlot for you. And here's a picture from WinPlot, and as you can see, it's actually pretty powerful and quite easy to use. So look for Jesse's thing there, and I will have hard copies of all these things will be available in the syllabus tab as well for you to use, in addition to recommending this video. Okay, so that's everything I think you need for the end game. Your proctors will be communicating with you about times and places and Zoom addresses and whatnot. So in closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. God bless you all.